Energetics, enthalpy change, definition, heat energy transferred in reaction at constant pressure. Enthalpy of formation, enthalpy change, 1 mole of compound is formed from elements. 1 mole enthalpy of change, when 1 mole of compound is formed from its element in standard states under standard conditions. 1 mole of compound is formed from its elements under standard states into under standard conditions. And that F just means formation, and there you go. The units for enthalpy change, delta H, kilojoules multiplied minus 1. This bit tells you that the substances were in the standard state and measurement under standard conditions. Enthalpy of combustion, you got that little C, tells you combustion. Enthalpy change, 1 mole of a substance is completely burned in oxygen under standard conditions. Exothermic reactions give out energy, therefore delta H negative, and temperature increases. 2 examples of exothermic reactions. Oxidation reactions are exothermic. Combustion of fuel like methane, CH4 plus 2O2 to form CO2 plus 2H2O. Or oxidation of carbohydrates like, for example, glucose and respiration. Both of these, combustion of fuel like methane, oxidation of carbohydrates like glucose, respiration, both examples of exothermic reactions. Oxidation reactions are exothermic, generally exothermic. Endothermic reactions, they absorb energy, delta H is positive, temperature decreases. Thermal decomposition of calcium carbonate is endothermic. CaCO3 solid, arrow CaO solid plus CO2 gases. The main reactions of photosynthesis endothermic as well. Sunlight, as for example, the sunlight supplies energy. Specific heat capacity of water, amount of heat energy it takes to raise the temperature of 1 gram of water by 1 Kelvin. Say key fact about endothermic reactions, need energy to break bonds. Bond breaking is endothermic. Stronger bonds take more energy to break. Say key fact about exothermic reactions, energy released when bonds are formed. Bond making is exothermic. Stronger bonds release more energy when they form. Enthalpy change of reaction is the overall effect of two changes. If we need more energy to break bonds than released when bonds are made, delta H positive. If it's less, delta H negative. Bond enthalpy, energy required to break bonds. The energy needed to break a bond depends on the environment it is in, and that's really important. It's not the same on the same environment in different environments. It depends on the environment it's in. Mean bond enthalpy, average energy needed to break a certain type of bond over a range of compounds. Why is the data book value for bond enthalpy OH different? Because it's average for a bigger range of molecules, not just water. For example, includes the OH bonds in alcohols and carboxylic acids too. Why mean bond enthalpy is always positive? Breaking bonds always endothermic. Yeah, breaking bonds, bond breaking, endothermic, bond making, exothermic. Breaking bonds always endothermic, mean bond enthalpy is always positive. Enthalpy change of reaction, total energy absorbed minus total energy released, and this is using mean bond enthalpies. And enthalpy change is calculated using mean bond enthalpies aren't exact as we use average values. Hess's law, the definition, the total enthalpy change of a reaction is independent of the route taken. The total enthalpy change of a reaction is independent of the route taken.